Welcome back again. We had completed revision of chapter similarity in chapter Pythagoras theorem. Now today we'll start with revision of chapter circles. So first of all, let's go through the basic definitions which are there in this chapter circles. Now if you look at the figure check, you've got circumference, radius, diameter, chord, segment, point of contact, tangent. So first let us go through all these definitions which are there. The circumference of the circle is the distance around it. So the border of the circle, check this border of the circle is the circumference. Diameter, any straight line that passes through the center of the circle to 2 points on the perimeter. So if you are taking any 2 points on the perimeter and the line which is going to pass through the center, the line which passes through the center and which touches any 2 points on the perimeter is called the diameter. Radius, any straight line that originates at the center of the circle and ends at the perimeter. So the line which is going to start from the center and which will go to the perimeter. Chord, a straight line whose ends are on the perimeter of the circle. The diameter is the longest chord possible. So check any 2 points on the perimeter when the line is joining those points on the perimeter. Now here it can pass through the center or it may not pass through the center. The diameter is the longest chord which is present. A segment, a part of a circle separated from the rest of the circle by a chord. Understand this. So the part which is separated from the rest of the circle. Understand, check this part and this part. When you draw a chord, the circle is divided into two parts. So those parts are called the segment of the circle. A tangent to the circle is a straight line which touches the circle at only one point. So when you draw a line which is going to pass outside the circle and which is going to touch the circle only at one point, you can see the point of contact. Understand, only that one point, we say that it is the tangent of the circle. Let's move ahead. The point of the contact, where the tangent is going to touch the circle. A part of the curve along the perimeter of a circle is called the arc. So you take a small part on the perimeter. Understand, you take a small part on the perimeter, that part will see that it is the arc of the circle. Angle on the major arc, the larger of two angles when a circle is split into two uneven parts, and this angle is going to be greater than 180 degrees. Understand this. So check, this is the major arc which is formed. So this is the angle at the major arc. It's always going to be greater than 180 degrees. The angle at the center of the triangle, understand, between the two lines that intersect with the perimeter. Understand this, the angle which is formed at the center, angle which is formed at the center of the circle, check, is already given in the figure. The angle which is formed at the center of the circle. Now this is going to form a triangle here. If you draw this red lines, if you say, and if you join those base, it's going to form a triangle. So it is written the angle at the center of the triangle between the two lines that intersect with the perimeter. These lines are intersecting with the perimeters. The small of the two angles when a circle is split into two uneven parts, which is less than 180 degrees, the angle which is less than 180 degrees is the minor arc. Then you have got this sector. a portion of the circle which resembles a slice of a pizza. You have seen a pizza. So when you cut pizza into small parts, understand those small parts, you can see that they are the sectors. Is this clear to all the students? Any doubts still here? Should we move ahead? No difficulty till here? This for the basic definitions. Now we'll go through some theorems which are there. These theorems are very important. I have told you already that you need to make a separate book for the theorem so that when you are going to start revision, understand, you'll not waste much of your time in that. A tangent at any point of a circle is perpendicular to the radius at the point of contact. This is the very important theorem because you are going to apply this theorem to solve the questions. Understand, this is the figure of this. Check the tangent at any point. Understand, means say line L is the tangent. Okay, point A is the point of contact and OA is the radius. We have to prove that L is perpendicular to OA. Given line L is the tangent to the circle with center O at point of contact A. To prove line L perpendicular to radius OA. Now we are going to go ahead with the indirect proof. You don't have direct proof for this. We'll go with the indirect proof. We assume that line L is not perpendicular to segment OA. So suppose segment OB is drawn perpendicular to line L. Understand this. Now if you look at this, check OA was the original line. Understand this. OA was the original line here. But here you have drawn OB. Here what you have done, you have drawn OB. Is this clear? Check. OA was the original line in this. But you are assuming that OB is perpendicular. You are assuming that OB is perpendicular. Of course, B is not same as E. So B is not same point as E. Now take point C on line L such that A dash B dash C and BA equals to BC. Understand what you have taken? You have taken point C in such a way that distance BA is going to be equal to distance of BC. Now in triangle OBC and triangle OBA, so here there are two triangles which are formed. You'll get segment BC congruent to segment BA. This is by the construction whatever you have done. You will get angle OBC equals to angle OBA. Segment OB congruent to segment OB. Therefore, you will get triangle OBC congruent to triangle OBA by side angle side test. Therefore, OC equals to OA. But OA is the radius. Now, this is given to us. Understand? Segment OA is the radius. This is given to us. So now this becomes the contradictory statement. Therefore, segment OC must also be the radius. Now C lies on the circle. That means line L intersects the circle in two distinct points A and C. Understand? See, if you're getting OC as the radius, you're going to get that C lies on the circle. This means that line L intersects the circle into two distinct points A and C. But line L is the tangent. But what we have got line L as the tangent. So by definition of tangent, it intersects the circle only in one point. It needs to intersect the circle at one point. So our assumption that line L is not perpendicular to radius OA is wrong. So whatever we have assumed, understand that assumption is wrong. So as our assumption is wrong, you will get line L perpendicular to radius OA. Is this clear? Very important theorem. We apply this theorem to solve the questions. Move to the next theorem. Tangent segment theorem. The tangent segment drawn from the external point to the circle are congruent. Understand? The given segments PD and QD are tangents to the circle from external point D. So point D lies outside the circle, and from that point D you are drawing two tangents to the circle, and you have to prove that these tangents are congruent, that is segment DP congruent to segment DQ. Now for this you need to do a small construction. You have to draw radius EP and radius EQ. What do you have to do? You have to draw radius EP and you have to draw radius EQ. Proof. Now let's begin with the proof. Now once you have drawn this radius, what you have got? You have got this divided into two triangles. So in triangle PAD and triangle QED, what you will get segment PA congruent to segment QA. This is the radii of the same circle. These are the radii of the same circle. Segment AD is congruent to segment AD. Now this is the common side. And you'll get angle APD is congruent to angle AQD, and that is equals to 90 degrees. This is by the tangent theorem, the tangent radius theorem, which we had studied just now. Understand this? So what you'll get triangle PAD congruent to triangle QED. Therefore, segment DP congruent to segment DQ. Let's move ahead. Theorem of touching circles. If two circles touch each other, their point of contact lies on the line joining their centers. So check. Now the circles, they can either touch externally or they can touch internally. So there are two possible cases, case A and case B given. C is the point of contact of the two circles with centers A and B. So you have taken two circles with center A and B, and point C is contact for both. To prove point C lies on line AB, sir. Point C lies on line AB. So you have to prove that this point C, it lies on line AB. So if you're joining this line also, to get that C, it lies on line AB after extension. Now, let line L be the common tangent passing through C of the two touching circles. So assuming that L is the common tangent which is going to pass through this point of contact, that is point C. Now line L perpendicular to segment AC, line L perpendicular to segment BC. Now by the tangent theorem, understand this, what you'll get, AC is perpendicular to tangent L, BC, which is the radius of the other circle, is perpendicular to tangent L. So these two radii, they are perpendicular to the tangent. So therefore segment AC perpendicular to line L, segment BC perpendicular to line L. So through C, only one line perpendicular to line L can be drawn. So from this point C, you can draw only one line which is perpendicular to the tangent. So that means that points C, A, B are collinear. That means that points C, A, B are collinear. So that means that means whatever you have to prove, that point C lies on line AB. So as they are collinear, you'll get that point C lies on line AB. Now the next theorem, chords corresponding to the congruent arcs of the circle, or instead of a circle it can be congruent circles also are congruent. Check, we assume that arc AC and arc ED, they are congruent. Now in circle with center B, arc APC, check this, arc APC is congruent to arc DQE. But to prove that chord AC is congruent to chord DE. Proof. Triangle ABC and triangle DBE. Understand, you have to get these triangles congruent. Triangle ABC and triangle DBE. Get side AB congruent to side DB. Reason for that is the radii of the same circle. Side BC congruent to side BE. Again, the reason is going to remain same. They are what? The radii of the same circle. We've got angle ABC is congruent to angle DBE, the measures of the congruent arcs. So therefore, you get triangle ABC is congruent to triangle DBE by side angle side test. You've got the two triangles congruent. As the two triangles are congruent, you get the corresponding sides also congruent. You'll get chord AC congruent to chord DE, corresponding sides of the congruent triangles. Is this clear to all the students? So let's move ahead. This theorem can come in your exam. It can be asked. Now we'll move to the next part, inscribed angle. Now what is an inscribed angle? This inscribed angles, to get the values of this angle, the questions based on this are asked in your examination. So you have to be very clear with the concept of the inscribed angle. The angle formed in the interior of the circle when two secant lines intersect on the circle. Equivalently, an inscribed angle is defined by two chords of the circle sharing an endpoint. So that means check if two chords they meet at one point. Understand? Means they are sharing an endpoint. The angle formed there is the inscribed angle. Check the figure here. Check if you're considering PD and DQ as the secant. Understand? D is the point of contact. So the angle formed here, PDQ, is the inscribed angle. Or say if you're considering chord AD and BD, if you're considering chord AD and chord BD, check D is the point of contact. Understand? C is the center of the circle. Vertex D of angle PDQ lies on the circle. Arms of PDQ intersect the circle at A and B. Such an angle such an angle is called an angle inscribed in the circle or in the arc. So such an angle which is formed, that is angle EDB. Understand? Or it can be PDQ, is called an inscribed angle. So angle ADB is inscribed in the arc ADB. So angle check ADB. This is the arc ED. Next concept is the intercepted arc. The part of the circle's circumference formed when the line or lines cut across it. An intercepted arc can be defined as an arc formed when one or two different chords or line segments cut across a circle and meet at a common point called a vertex. It is important to note that the lines or the chords can either meet in the middle of the circle, on the other side of the circle, or even outside the circle. Now check here, if you get the red arcs which are shown in the figure, they are all your intercepted arcs. Understand, an intercepted arc can be defined as the arc formed when two or different chords or line segment cut across a circle and meet at a common point, which is called a vertex. So check if these two lines are meeting at this common vertex. These two lines they meet at a common vertex. These two lines meet at a common vertex. So that means, understand, this vertex which is there, it can be in the middle of the circle, on the circle, or it can be outside the circle. So let's move ahead. Inscribed angle theorem, very important theorem. The measure of the inscribed angle is half the measure of the arc intercepted by it. Now here also, see, based on this theorem, we've got questions. So application of this theorem, understand, you have to understand, because we use this theorem a lot in solving the questions. This is the figure of this given. In a circle with center O, angle BAC is inscribed in arc BAC. Arc BDC is intercepted by the angle. So to prove that angle BAC is half measure of arc BDC. Constructions, what you'll do is you'll draw ray OA. It intersects the circle at E. Draw radius OC. After drawing this radius OC, what you'll get this triangle AOC as an isosceles triangle. Understand? Check. Proof. So let's begin with our proof. In triangle AOC, side OA is congruent to side OC. You've got side OA, understand, congruent to side OC. The reason for this is that the radii of the same circle. Now you know in a triangle when two sides are equal, triangle is said to be the isosceles triangle. So by applying that property, you'll get the base angles equal. So you'll get angle OAC equals to angle OCA. OAC equals to angle OCA. This is the theorem of the isosceles triangle. When you are assuming that angle to be x. So angle OAC equals to angle OCA equals to x. This is your statement number 1. Now, angle EOC. If you look at angle EOC, this angle EOC. Listen, this is exterior angle to this triangle. With respect to this triangle, this is the exterior angle. So by applying the exterior angle theorem, understand? Applying the exterior angle property, you'll get angle EOC equals to angle OAC plus angle OCA. Now, when you substitute the values in terms of x, what you'll get? X plus x equals to 2x. But angle EOC, now if you like, O is the center of the circle. So angle EOC, which is formed, it is in the center of the circle. So that angle is called as the central angle. Therefore, measure of arc EC going to be equal to 2x by the definition of the measure of the arc. Now you know the measure of the arc, it directly corresponds to the value of the central angle. So with respect to that, what you are going to get? You'll get measure of arc EC equals to 2x. Now from 1 and 2, angle OAC equals to angle EAC equals to half measure of arc EC. This is your statement number 3. So when you're going to combine 1 and 2, understand, you are going to get this statement that angle OAC equals to angle EAC equals to half measure of arc EC. Now similarly, drawing OB on the other side, understand, drawing OB on the other side, you can get angle EAB is half measure of arc BE. Angle EAC plus angle EAB. You have to add both the statements. Understand? Statement number 3, statement number 4. You are going to add that. Angle EAC equals to, angle EAC plus angle EAB equals to half measure of arc EC plus half measure of arc BE. Understand? This half which is there is going to come common for both. Check this half and this half is going to come common for both. So what you'll get? You'll get angle VAC equals to half common measure of arc EC plus measure of arc BE. Understand? Check, you have got measure of arc EC plus measure of arc BE. So when you add these two arcs, what you'll get? Measure of arc BD. Understand? You'll get measure of arc BDC. So that equals to half measure of arc BDC. So let's move ahead to the next part, the corollaries of inscribed angle theorem. This we are going to apply. Application is very important. Angles inscribed in the same arc are congruent. Check, same arc. Now if you look here, arc PQR, if you are going to consider, you are going to consider arc PQR. So check angle 1 and angle 2. Understand? They are inscribed in the same arc, they are formed in the same arc. So these angles are going to be congruent. So angles inscribed in the same arc are congruent. Angles inscribed in a semicircle is a right angle. So this angle ABC, understand, is inscribed in the semicircle. Understand? So that value of the angle is 90 degrees. Understand? Angle inscribed in the semicircle is a right angle. Now, the most important theorem, cyclic quadrilateral. This theorem will come in your examinations. So, to understand the proof of this, if the vertices of a quadrilateral lie on the same circle, then it is called a cyclic quadrilateral. So, that means if all the vertices of the quadrilateral lie on the same circle, then it is called the cyclic quadrilateral. This is the figure of this check. Vertex A, vertex B, vertex C, vertex D. They are lying on the same circle. We have got a theorem based on this theorem of cyclic quadrilateral. The theorem states that the opposite angles of the cyclic quadrilateral are supplementary. You have to prove this, that the opposite angles of the cyclic quadrilateral are supplementary. First, we'll look what is given to us. We are given that quadrilateral ABCD is cyclic. You have to prove angle B plus angle D equals to 180 degrees. Angle A plus angle C equals to 180 degrees. Check B and D are the opposite angles. A and C are the opposite angles. Proof. Arc ABC is intercepted by the inscribed angle EDC. Therefore, angle ADC is half measure of arc ABC. Similarly, angle ABC is the inscribed angle. It intercepts arc ADC. So what you'll get? You'll get angle ABC equals to half measure of arc ADC. Now, if you combine both the statements, check you've got arc ABC and arc EDC. Understand? When you add these two arcs, understand? This value is going to be equal to the value of the complete circle. So, measure of angle EDC plus angle ABC equals to half measure of arc ABC plus half measure of arc EDC. From statements 1 and 2, we are going to add 1 and 2. So half will come common. Half measure of arc ABC plus measure of arc EDC. Now these two arcs ABC and EDC, they constitute a complete circle. So the value is 360. So that you'll get half into 360. So when you do the calculations, you'll get that equals to 180 degrees. So you've got angle EDC and angle ABC. Understand? Equals to 180 degrees. Now, similarly, you can prove that A plus C equals to 180 degrees. Understand? If you take the two other angles and the two other arcs. Is this clear to all the students? No doubt still here? So let's move ahead. Converse of cyclic quadrilateral theorem. We just go with the statement of this. If the pair of opposite angles of the quadrilateral is supplementary, the quadrilateral is cyclic. So if the opposite pairs of the angles of a quadrilateral is supplementary, the quadrilateral is said to be cyclic. The above converse gives us the condition to ensure the existence of the circumcircle of the quadrilateral. Now the last theorem of this. If two points on the given line subtend equal angles at two distinct points which lie on the same side of the line, then the four points are concyclic. Is this clear to all the students? Any doubts still here? so that we can revise the theorems you want. Others will solve some questions which are based on this chapter, which are very important. Understand? We are going to do some revision of this. So any difficulty, students, you all can let me know. So let's move ahead. Check the first question. The length of the tangent from point A at distance 5 centimeters from the center of the circle is 4 centimeters. Let us find the radius of the circle. Let's check EB. Understand is the tangent. Understand, and point A, there are distance of 5 centimeters from the center. You have to find the radius, that is OB. Now you know the property of tangent and radius. The tangent to a circle is perpendicular to the radius through the point of contact. Now here the point of contact is B. That means OB is going to be perpendicular to EB. So what you will get? You get angle OBA equals to 90 degrees. Here it's OTA, but it should be OBA. Now in triangle OTA, we have, instead of this point B, we take that as point T. So now in triangle OTA, we have OP square equals to OT square plus PT square. This is check. OP square equals to OT square plus PT square. So you'll get 5 square equals to OT square plus 4 square. You'll just substitute the values. Here there is mismatch of the names, so don't get confused with those names. Understand? You get OT square equals to 5 square minus 4 square. Now here what we have done is we have applied the property of A square minus B square. We have applied the property of A square minus B square. A square minus B square is A plus B into A minus B. So what we have done is we have got this as 5 minus 4 and 5 plus 4. Just clear, check A square minus B square. It is in that form, A square minus B square. So that we have taken as 5 minus 4 into 5 plus 4. So you'll get that 5 minus 4 is 1, 5 plus 4 is 9. So 1 into 9 equals to 9. So that equals to 3 square. So OT equals to 3. Thus the radius of the circle is 3 centimeters. Is this clear to all the students? Any difficulty in this, students? You all can let me know. Any difficulty in this, students? Can we move ahead with this? Now I want you all to do this before me. Prove that angle between the two tangents drawn from an external point to the circle is supplementary to the angle subtended by the line segment joining the points of the contact at the center. This is the figure of this. You have to prove angle AOB plus angle APB equals to 180 degrees. How will you prove this, students? Come on. Can anybody help me out with this solution? You'll have to try this out with me. See, given what we are given PA and PB. We are given PB and PA are the tangents from external point P to the circle with center O. Understand? This is the first statement which is given to us. Understand? Now check. In right triangle OAP and triangle OBP, what we have? PA equals to PB, tangents to the circle from the external point P. OA equals to OB, radii of the same circle. OP equals to OP, common. So therefore, by SSS test of congruency, you get triangle OAP congruent to triangle OBP. Understand? So the corresponding parts are equal. So that means corresponding sides and the corresponding angles of this are going to be equal. So you'll get angle OAP equals to angle OPB and angle AOP equals to angle BOP. You'll get angle APB equals to twice angle OPA and angle AOS equals to twice angle AOP. But angle AOP is 90 degrees minus OPA. So twice of angle AOP equals to 180 minus twice angle OPA. You just substitute that. You'll get angle AOP equals to 180 minus APB. So you'll shift minus APB to the other side. You'll get angle AOP plus angle APB equals to 180 degrees. Is this clear to all the students? Any difficulty in this? Any difficulty in this? You all can let me know. Now this question number 3. The two concentric circles are of radii 5 centimeters and 3 centimeters. Find the length of the chord of the larger circle which touches the smaller circle. What is meaning of concentric circles? Anybody can explain what is meaning of concentric circles? Which have got the same centers are called the concentric circles. Check this. O is center for the smaller circle as well as the bigger circle. You have to find the length of the chord of the larger circle which touches the smaller circle. You have to find length of AB. In figure, O is the common center of the given concentric circles. AB is a chord of the bigger circle such that it is a tangent to the smaller circle at B. Yes, Mansi? Yes, Mansi, beta, what is your doubt, beta? You can ask, unmute and ask.
तुमची वॉइस नाही येते.
Beta. My voice is not audible, beta. Now, is my voice audible?
Continue.
Ma'am, voice is audible, no,
Yes,
ma'am?
yes, it's audible.
Yeah,
Yes, yes.
yeah. Thank you. So now check. In figure, O is the common center of the given concentric circles. AB is the chord of the bigger circle such that it is the tangent to the smaller circle at P. Now, since OP is the radius of the smaller circle through point P, the point of contact, therefore OP is perpendicular to AB. Now check, when you're considering this smaller circle, when you're going to consider this smaller circle, now AB, the chord of the bigger circle, is going to become the tangent of the smaller circle. Understand this. It is going to become the tangent of the smaller circle. So with respect to that, the property of this radius and the tangent, by the property of this radius and the tangent, what you'll get, they are perpendicular. Understand? So you'll get OP is perpendicular to AB. Therefore, angle APB equals to 90 degrees. Also, a radius perpendicular to a chord bisects the chord. Now you know the radius which is drawn perpendicular to the chord. Now you are going to consider the bigger circle here. You are going to consider the bigger circle. Understand? You're going to consider the bigger circle. So that property of 9th standard which I studied. See, AB is the chord and OP is perpendicular. So what happens? It divides the chord into two equal parts. With respect to that, now in triangle APO, OA square equals to AP square minus OP square. It should be plus. Understand? Yeah, it's by mistake. AP square plus OP square. So you will get 5 square equals to AP square minus 3 square. So AP square, by mistake, AP square plus 3 square. So plus 3, when it goes to the other side, becomes minus 3. Understand? So AP square equals to 5 square minus 3 square. So 5 square minus 3 square, what you will get? AP square equals to 5 minus 3 into 5 plus 3. Here check, I have applied property of A square minus B square. I have applied property of A square minus B square. We'll get 5 minus 3 into 5 plus 3. So 5 minus 3 equals to 2, 5 plus 3 equals to 8. So what you will get? You get that as 2 into 8. So AP square equals to 16. So that is 4 square. So AP equals to 4 centimeters. Now is our answer over till here? We have got value of AP, we have got value of AP, we have got value of AP. Understand? We've got value of AP, but we want the length of chord. Now check AP, which we have got is the half value of this chord. Understand? AP is the half value of this chord. So this chord AB is going to be double of this, twice of this. So 2 into 4, that is 8 centimeters. Is this clear to all the students? Now you can remove the screenshot of this if you want, so that we'll move ahead to the next question. Now in figure, if TP and TQ are the two tangents to the circle with center O, so that angle POQ is 110, then find angle PTQ. Check, one angle is given to you as 110. You have to find this value PTQ. This question is going to come for 2 marks in your exams. Understand? Check, very easy questions. Now if you just look at the figure, you should get your answer. Is anything clicking to your mind? Check, PT is the tangent, O is the radius. Again, same thing. TQ is the tangent, OQ is the radius. So by this tangent radius property, what you will get? You get OP perpendicular to PT and OQ perpendicular to QT. So that means angle OPT and angle OQT are 90 degrees each. So in quadrilateral check, you have got 3 angles. In quadrilateral, you have got 3 angles. So can you find the 4th angle? You can easily find the 4th angle if you know the values of the 3 angles. Now in quadrilateral TPOQ, we get angle PTQ plus 90 degrees plus 110 degrees plus 90 degrees equals to 360 degrees. Now check, I have not written the reasons in this question. Understand? Check, what is the reason for this? What is the reason for this? Those reasons you have to write. Those reasons you have to understand and write. Understand, what is the reason for this? What is the reason for this? Angle PTQ plus 90 plus 110 plus 90 equals to 360. That reason you all have to write. I've kept that for you. answer. So therefore, angle PTQ plus 290 degrees equals to 360 degrees. So angle PTQ equals to 360 minus 290, that is equals to 70 degrees. So with respect to this, you'll get angle PTQ as 70 degrees. So this kind of questions, they come for 2 marks in your examinations. Very easy to answer. Understand, you have to just apply the property. Let's move to the next question. Now in figure, chord MN and chord RS intersect each other at point P. If PR equals to 6, PS equals to 4, MN equals to 11, we have to find value of PN. Understand? Now we'll look at the figure. Check. Now the chords are intersecting each other in the interior of the circle. So there is one property of the intersecting chords. So by the theorem of the intersecting chords. So what you will get by this property? You'll get Pn into Pm equals to PR into PS, the first statement. I will substitute the values. Now you assume Pn as x, which value you have to find. So Pm would be 11 minus x. Understand, we are assuming this Pn as x. This complete value is given to us as 11. So this is going to be 11 minus. Understand? So substituting the values in statement 1, x into 11 minus x equals to 6 into 4. So 6 into 4 is 24. So plus 24, when it comes to the other side, becomes minus 24 x into 11, that is 11x minus x square minus 24 equals to 0. Now check. This is in form of a quadratic equation and value of x square is negative, that is minus. So what you're going to do is you'll make that positive. So that means you're going to multiply the whole equation with minus 1. So when you multiply the whole equation with minus 1, what do you get? You get x square minus 11x plus 24 equals to 0. So whatever values were positive will turn to negative and your negative values will turn to positive. Now can anybody tell me the factors of this? What are factors of this? X square minus 11x plus 24. Come on, try this out. X square minus 11x plus 24. What are the factors of this? 8 and 3. So you'll get that as x minus 3 into x minus 8 equals to 0. So x minus 3 equals to 0 or x minus 8 equals to 0. So you'll get x is equals to 3 or x equals to 8. So therefore Pn equals to 3 or Pn equals to 8. Because of the quadratic equation, you've got the two solutions for this. Any difficulty till here, students? Any difficulty till here? No difficulty. So let's move ahead to the next part, MCQs. I want everybody to try this out.
Sir, already it's time up. Can we stop here?
Okay, ma'am. Okay, we'll stop here, ma'am. Then we'll stop here, ma'am. Yeah.
Okay. Thank you,
We'll,
sir.
yeah, thank you, ma'am. Thank you.
Thank you, students.
I leave